Hello everyone. In this video, I will explain you my second internal test solution of data science. So first question, I explained you the first question in the previous video, first internal test solution of data science. Now start with second question. So explain decision tree process of data science and its various approaches to construct a decision tree from the database, and how these structures and algorithms can be applied to effectively classify complaints into appropriate IPC or BNS sections. So first of all, a decision tree is a supervised learning. So decision tree is a supervised learning. Supervised meaning you have to train your data set to perform a specific operation. Algorithm that resembles a flowchart with a decisions or test at each node and the outcome of those decisions or test at a branches. So it's popular technique for classification and regression tasks. So the process of decision tree is first is data preparation. In this, data cleaning handles missing values, outliers and inconsistencies. Then we have feature engineering. Create a new feature or transform existing ones to improve model performance. Then we have data splitting. So divide the data set into training and testing sets. Then tree construction. So in this, first is root node selection. So choose the attribute the best splits the data based on a specific criteria, like you have information gain or Gini impurity. Then we have recursive partitioning. So create a child nodes by splitting the data further based on the chosen attribute. Then stopping criteria. So decide when to stop splitting. Then maximum depth reached. Maximum number of samples per leaf node. Maximum information gain. Then third is pruning. So reduce overfitting. Overfitting means remove unnecessary branches to prevent the tree from becoming too complex and overfitting the data, the training data. Then pre-pruning. Stop growing branches early based on specific criteria. Then we have post-pruning. Remove branches after the tree is fully grown. Approaches to construct our decision tree. So first is ID3, like iterative dichotomizer 3 uses information gain as a splitting criteria. Select the attribute with the highest information gain at each node. Then we have C4.5. So extension of ID3 that handles continuous attributes and missing values. Uses gain ratio as the splitting criteria. Then we have CART, C-A-R-T, that is classification and regression trees. So can be used for both classification and regression tasks. Use Gini impurity or variance reduction as the splitting criteria. Then we are applying decision tree to classify complaints. So to classify complaints into appropriate IPC or BNS sections using a decision tree, we need a data set containing historical complaints data with corresponding IPC and BNS section. So steps. So first step is data preparation, in which clean and pre-process the complaint text data, like remove stop words, stemming, tokenization. Then extract relevant features from the text such as keywords, phrases or sentiments. Then we have feature engineering. So create numerical features from the text data like TF, IDF words, embeddings. Then model training. So use a decision tree algorithm like C4.5 or CART to train the model on a prepared data set. So the model will learn the decision rules based on the features and their relationship with the IPC and BNS sections. Then we have model evaluation. Evaluate the model's performance using matrices like accuracy, precision, recall, and F1 score. Then consider using a cross validation to assess the model's generalization ability. Then model deployment. At last, this is a model deployment. So in this, deploy the trained model to classify new complaints, and the model can be integrated into a web application, API, or other system to automate the classification process. Then our third question is, what matrices are appropriate for assessing the performance of algorithm used in text mining, and give a detailed matrices that evaluate the effectiveness and accuracy of text mining techniques. So this is evaluation matrices for text mining algorithms. So in this we have classification matrices like accuracy, precision, recall, F1 score, confusion matrix, Karinsky her. So these are the appropriate performance matrices, like accuracy over proportion of correct predictions. Precision is a proportion of positive predictions that are actually positive. Recall, proportion of actual positive cases that are correctly identified. Like F1 score is harmonic mean of precision and recall, providing a balanced measure. Then we have confusion matrix, a table that visualizes the performance of classification model showing correct and incorrect predictions, and these all other matrices. Thank you. That's all for the today's video.